Good morning to all. Today we are going to discuss of the scheduling algorithms. Before scheduling algorithms, we know already the process states. There are 5 states in the process, that is new, ready, run and terminated, and the schedulers are going to be used to send the process from one state to another state. Here there are some scheduling algorithms for schedules the processes. Mainly the CPU scheduler is going to select a process from among the ready processes to execute in the CPU, and CPU scheduling is the basis for multi-programming environment. Why? Because in the multi-programming environment multiple programs are going to be run at a time, so one of the process is going to be selected for execution. Who is going to select that? The CPU scheduler is going to select the processes to execute, and by using the CPU utilization may be increase. Why? Because one process need not wait for executing other process to complete. Instead of it is waiting, it will ready for the process to complete its execution. Here there are some scheduling algorithms we have. Before that, the scheduling is divided into two different types of scheduling algorithms, that is preemptive scheduling algorithms and non-preemptive scheduling algorithms. First we'll discuss about the preemptive algorithms. The preemptive algorithms means processes can be released forcibly. Whatever the process is running in the CPU, that is going to be forcibly released before completion of its execution. That is called as the preemptive processes, preemptive scheduling. And non-preemptive we'll discuss. Non-preemptive processes will be with the process throughout its execution. A process cannot be forcibly released from its process before its execution completes. Those are called as a non-preemptive. Preemptive means which is going to be forcibly released. Non-preemptive means which cannot be released until its execution completes. That is non-preemptive schedulings. There are different scheduling algorithms. We have the CPU scheduling algorithm. First one FCFS algorithm, second one SJF, shortest job first, and priority scheduling algorithms, round robin scheduling algorithm. Now we'll discuss about the first come first serve scheduling algorithm. This first come first serve scheduling algorithm is the simplest scheduling algorithm, and here the process request for the CPU first, it is allocated for the CPU first. Means whichever the process comes for the execution first, that process is going to be executed first. And next the name also came like that only, which process comes first, that is going to be executed first. And next we have it is implemented using the FIFO queue structure. FIFO means the first in first out queue. The means it is in a queue structure. All the processes are in a queue. Which process in the queue first, that is going to be executed first. And this algorithm is non-preemptive. Already said the preemptive and non-preemptive means once the process allocate the resources, after completion of that process only it is going to release all the resources. Until its completion it is not releasing the resources. That kind of processes we can call as the non-preemptive processes, and it is not suited for the time sharing systems. Means in the time sharing systems processes some time is allocated for one process, after that again another process is going to be executed. Like that in a time sharing system, time slots are going to be allocated. Within the time slot only that process need to be executed. This algorithm is not suited for that that type of time sharing systems. Now we'll consider some example. That is there is a P1, P2, P3 processes. Those are waiting at a time. That instance is 0. Means at 0 instance, these P1, P2, P3 processor are arriving and having the CPU burst time is first process P1, P2, P3. Means how much time the process P1 require the CPU is 24 seconds, and the process P2 is requires 3 seconds, and process P3 is requires 3 seconds. Now we'll prepare the Gantt chart for this. Means first which process is going to be execute in the first come first serve algorithm. First P1 process will execute, after that P2 process will execute, after that P3 process will execute. Now we'll see Gantt chart for this CPU scheduling. In the Gantt chart we have P1. P1 it starts at 0th time and its completion time is 24 seconds. At this 24 seconds time, again the P2 is releasing all the resources CPU, and now the P2 process is going to be execute. After this completion at 27th second, now the P3 process is going to be execute, and the total time is 30 seconds to complete all these processes. Now we need to calculate the average waiting time. The average waiting time formula is the start time minus arrival time. Here average waiting time for P1 will calculate. Waiting time for P1. Waiting time for P1 is equals to, now what is the start time for P1? 0. At 0th second it started, and the arrival is also 0. So 0 seconds. Now the next process is P2. The P2 waiting time is start time is 24 and arrival time is 0. So 24 seconds is this process waiting time. And now we'll calculate the wait time for P3. P3 starts at 27th and arrival time is 0. Now 27 seconds. Now we'll calculate the average waiting time. The average waiting time is 0 plus 24 plus 27 by 3. Now this 4 plus 7 plus 4 and 51 by 3. Now 3 ones are 3 sevens are means 17. If you take this as a milliseconds, now the 17 milliseconds it is going to take for the execution of this all three processes, the waiting for all these processes, average waiting time. Now we'll calculate the turnaround time for this first come first serve. That turnaround time is total completion of this process, all three processes. Now the formula for the turnaround time is finish time minus arrival time. The first P1 process finish time is 24. At 24 second it is going to finish, and the arrival time is 0. And next P2. P2 turnaround time is it starts as it is completed its execution at 27 milliseconds and arrival time is 0. And next we'll calculate the P3. P3's finish time is 30, arrival time is 0. Now we'll calculate the average turnaround time. The average turnaround time is equals to 24 plus 27 plus 30 by 3. Now this is totally 81 by 3. 81 by 3 means 3 2s are 6, 3 7s are 21. So this is 27 milliseconds. This is a first come first serve scheduling, CPU scheduling algorithm. If for suppose